Engrams are physical and chemical changes in the brain that represent memories. They're the basic unit of a memory, made up of neurons that are clustered together from associations made during learning something. When a memory is recalled, the neurons that make up the engram are reactivated. The hippocampus encodes a cognitive map of experiences, giving them the context which they are stored and retrieved with. The experience of having a self is formed by how synapses are shaped by social experiences. By the age of 3, a child has begun to join her caregivers in mutually constructed stories of both imagination and reality. Relationships help sculpt what exactly will be remembered and how that memory is remembered. Relationships dictate that felt sense of self that remembers. Parents reminiscing about past events with discussion, comparison of self and other allows children to construct a coherent sense of self in time. The encoding process begins by stimuli being perceived into sensory memory, which are filtered through so that only the relevant chunks are left. If these bits of leftover information are rehearsed enough, they are encoded into long-term memory. Long-term memories are usually stored in the hindbrain and are retrieved in the cortex. The hippocampus is like a working memory box and encodes in a circuit with a prefrontal cortex. These neural representations are consolidated into long-term by unconsciously rehearsing the neural representations from cortical associational regions. Consolidation may involve reorganizing the existing associations, condensing memories, and incorporating newly learned information to free up the short-term memory box. This mechanism depends on REM sleep, which makes sense of experiences by recognizing the relevant information and clearing out the irrelevant information. Transient stress is modulated by norepinephrine, while glucocorticoids like cortisol are longer acting. The hippocampus has the highest density of receptors for these neurotransmitters and hormones. The excess cortisol might impede explicit processing, and noradrenaline might enhance the amygdalar implicit processing. In a trauma memory, the hippocampus does not explicitly encode the memory, but the amygdala implicitly holds it. This might happen because the trauma victim's attention was focused on a non-traumatizing aspect of the environment or was employing their imagination to completely dissociate from the experience. Reactivated or triggered upon a retrieval cue given by the environment, recognized by the body, then the brain. Social connections and discussion for meaning making and proper consolidation are a crucial aspect of adaptively encoding and consolidating the memory in a coherent fashion. Once encoded in the associational cortex, they no longer depend on the hippocampus for recall. Consolidation requires the entire brain to work in harmony for a fully integrated self. Some people respond to environmental triggers by being flooded with the implicit memories and emotions, losing the self-monitoring features of episodic recall and feel like a traumatic event is happening in the present. Other people experience triggers knowing about the traumatic event, but no sense of self. The capacity of the left prefrontal cortex to encode the episodic memory is still impaired. Patients with unresolved trauma feature asymmetrical hemispheric activation, with the right hemisphere dominant over the left. Because REM requires no novel neurotransmitter activity like norepinephrine, heightened stress hormones seen in PTSD impede REM sleep, which further hinders relevant associations being made, encoded, and consolidated into long-term memory.